In Unit 2, you learned about isosceles triangles and equilateral triangles. We're going to use those properties throughout our calculations in the rest of this unit. So you need to remember properties about an isosceles triangle. And we say that if two sides of the triangle are congruent, and that is identified or indicated rather by the congruency markers, then the angles opposite them are congruent because these are the angles opposite, and vice versa. So if I draw a triangle and all I say is these angles are congruent, then that means by definition these sides are congruent, and this little triangle I drew is an isosceles triangle. So you need to know that. Now let's talk about an equilateral triangle. That's kind of easy because all three sides are congruent, equal for equal, lateral for sides. And that means all three angles are congruent, and there is only one possible measure for those angles, and it's 60 degrees because it's 180 divided by 3 because all angles are congruent. So we're going to use that to do some algebra. All right, let's take a look at A. Finding side lengths and angle measures of isosceles and equilateral triangles. Look at the triangles and determine what kind they are. In A, we're trying to find the side AB. Now you look at this. You've got an angle that's 60 degrees and 60 degrees and 60 degrees. So this is an equilateral triangle. So therefore, all the sides are congruent. So the actual measurement of AB is the side, is 4. Okay, that's not so bad. Let's take a look at this one. Find the measure of angle F. Read these directions carefully, guys. Measure of angle F means you're looking for an angle, not the side. Okay, we have congruency markers here. Therefore, this is an isosceles triangle, which means angle D and angle F are congruent. All right, so let's do some math here. How many degrees are in a triangle? 180. Well, we've already have one angle, angle E, that's 100. Let's subtract that, and what do we have left? We have 80 degrees. Now we have 80 degrees that must be split equally between two angles. Divide that by 2, and you have 40. So the measure of angle F is 40, as is the measure of angle D. I'll put them over there, 40 and 40. Because 40 plus 40 plus 100 is 180. You're applying what you learned about triangles in Unit 2 because you learned the basics about equilateral and isosceles triangles. You learned about scaling triangles, and you also learned that the sum of the interior angles of a triangle is 180 degrees. We're putting it all together. Let's do another one. Find the measure of angle V. All right, what do we see here? We see all three sides have the same measurement, which means this is an equilateral triangle, which also means that all three angles are congruent, so there's only one possible angle measure. 60 degrees, 180 divided by 3. All right, in our last triangle, let's do this one. Find the measure of angle X. Now you're going to do a bit more applying. Look at your triangle. I see a congruency marker and a congruency marker. So this is an isosceles triangle, which means if angle Y is 40 degrees, angle W is 40 degrees. Little degree symbol. How many degrees in a triangle? 180. 180 minus 40 equals 100. So angle X is 100 degrees. Very sloppy. Okay, so you're using what you know and applying it. Let's go to the next page. Now we're going to do everybody's favorite. We're adding algebra. Yay! To this. So read the directions and mark up your pictures. JKL is isosceles, and the base is JL. What that means is angle J and angle L are congruent because those are the base angles. Let that sink in. In an isosceles triangle, base angles are congruent. We were told JL is the base, therefore angle J and angle L are congruent. We've got equations for angle J and angle L, but we've got to find the measure of each angle. What I'm going to do right here is set up what I'm looking for. I'm looking for angle J, angle K, angle L. I'm just going to set it up so I have a place to write my answers. All right? Let's analyze. Do we have a numerical measurement for either of those angles? We do not. Can we add those two angles and the mysterious angle K to get 180? Well, we can, but we don't even have a variable for angle K. But we do know that angle J is congruent to angle L. Well, let's substitute. Angle J is 4x plus 21. Angle L is 5x plus 11. Let's solve for x. They are congruent to each other, so they have the same measurement. 21 equals x plus 11. Now we're going to move the 11. We have 10 equals x. All right? So x equals 10. That's not an angle measurement, but x is our tool. I'll put tool here. Now we use it. Let's plug it in. 4 times 10 plus 21 equals 40 plus 21 equals 61. All right? So angle J should be 61 degrees. Now, angle L should be the same, but let's just check the math. It never hurts to do that. 5 times 10 plus 11 equals 50 plus 11 equals 61. Great! Angle L is 61 degrees. And how do we find angle K? Well, when we add them all together, they add up to be 180, right? So you could do it 61 plus 61 plus angle K equals 180. 122 plus angle K equals 180. Subtract 122 from both sides, and you get angle K equals 58. Now let me do a little quick numbering here so you see this was the first step, this was the second, this was the third, and this is the fourth. All right? The first step is going to be finding your x. It's for all of these. Your first step is finding your x. Sometimes your equations will be equal. Sometimes you're going to have to add them up to 180. You need to look at the triangle and determine what you know. If you're doing this on paper, mark it up on paper. If you're doing it in Alex, annotate all over that screen. The more you mark up, the better you are, and the more you'll keep straight. All right, we're going to go to a different color. Number 2. We know that EFG is isosceles with base FE. Tells me that angle F and angle E are congruent. Now I have equations for the measures of angle F and the measure of angle G. I need to find the degree measure of all the angles. So like last time, I'm just going to set up my little template here. E, measure of angle F, measure of angle G. And honestly, I should have done this here, math grammar, measure. Okay, this is where I'm going to put my answers. Alrighty, so what do we know? Well, is angle F equal to angle G? No, they're not equal because those are not congruent angles. Okay, so what do I do with angle E? I analyze. Angle F and angle E are congruent. Do we know the measure of angle F? No, we don't. But we know what we can put there. We will call it 5x plus 17 degrees because they are congruent. So they'll have the same equation. Alrighty, now I have equations for all three angles. Well, if I add all three angles up together, they add up to 180. So I think that's what I'll do. And let me show you, I'm going to bring in a little bit of the angle addition. Let's do angle F plus angle E plus angle G equals 180. And now I'm just going to substitute. 5x plus 17, and you don't need your parentheses, by the way, because the parentheses only show you that that entire equation goes with that angle. So plus 5x plus 17 plus G is 4x plus 20 equals 180. Now we're going to combine like terms. Some of you forget, because my x's are on one side of the equal sign, all I'm going to do is add them together. 5x, 4x is 14x. Plus, now I'm going to add my integers. 17 plus 17 is 34 plus 20 is 54. So 14x plus 54 equals 180. Let's keep on going. Move the 54. And I have 14x equals 126. And divide both sides by 14. 9, yep, x equals 9. Okay, that's hard to do in my head. So x equals 9. Step 1. This is my tool. Okay, I found it. Now I'm going to use my x. All right, step 2. Doesn't matter which order you do the angles. I'm just going to go E because that's what I have. 5 times 9 plus 17 equals 45 plus 17 equals 62. All right, so the measure of E is 62 degrees, as is the measure of F. They have the same equation. So there's no need to do that same math. Let's do this one. 4 times 9 plus 20 equals 36 plus 20 equals 54. Now I could have done it a different way. I could have done 62 plus 62 plus angle G equals 180. 124 plus angle G equals 180. Subtract 124 from both sides. Angle G equals 54. Either way, you're going to get the right answer. So it started off looking complicated, but it is not. Look at the picture, read the words, and mark up your picture. All right, here we're shifting gears. We're not doing math right now. We're analyzing pictures. All right, you're going to look at the drawing of the triangle and you're going to determine what these segments are. So segment, we're going to say segment WV. What is segment WV? So let's look. Well, it's perpendicular because you have the right angle symbol, and if you'll notice, VY and XV are congruent. So this is also bisecting. It's bisecting y, x. So this is a perpendicular bisector. We call it exactly what it's doing. WV is bisecting segment or side YX, and it's doing it in a perpendicular manner. Okay, now let's look at this one. ZV, what's happening here? Well, I can see that angle Z is bisected. And I say bisected because you have two congruency markers here. I just hid them. You have two congruency markers here, 1 and 2, which means angle YZV is congruent to angle XZV. So angle Z has been bisected. So we call this CV is an angle bisector. The symbols told us so. Now look at this one. We're looking at segment AD. It connects the vertex to the midpoint of the side opposite the vertex. A vertex is any point in the triangle. All right? It doesn't matter if it's B, A, or C. They're all vertexes. So what we're seeing here is BD is congruent to CD. This D is the midpoint, which means AD is the median. It is not the perpendicular bisector because there is no right angle marker. See, do we see one? No, we do not. There's nothing like that there, so I'm going to erase it. Okay, it is the median. Now the last type we're going to do is GI. Whoops. Segment GI. It connects a vertex to the side opposite and is perpendicular. So we see it's perpendicular. Perpendicular. But do you see any congruency markers anywhere? Is FH being bisected? It is not. This is called the altitude. Now you're going to be using the altitude later on in semester 2 when you have to calculate area and volume. So the altitude is a line drop from the vertex to the opposite side, and it makes a right angle. All right, next page we're going to apply them. Here's where we apply them. We're going to select everything that describes GI. Look at the picture. The only thing we have is a right angle marker. Is it bisecting? Is GI bisecting FH? It is not. So it can't be a perpendicular bisector. Is angle G bisected? There are no markers. It is not. Is FGH, the median, is the line from G bisecting FH? It is not. It is, however, the altitude. And I'll give you a hint. I have never yet seen more than one choice. It's rare at this point to see that. It can if you have a isosceles triangle, but we're not drawing those right now. Okay, let's look at B. Again, we're going to select everything that describes ZV. This is what we see. Perpendicular bisector, no right angle markers. Angle bisector of angle Z. We have two congruency markers. It is an angle bisector. Okay, the median of the triangle, no. XY is not bisected. And the altitude, I don't see an altitude. I don't see a perpendicular marker. And it's not none of the above. Last one. Analyze the picture. I have congruency markers. Well, that means it can't be an angle bisector. I do not see any perpendicular line. I don't see a perpendicular indicator, so it can't be a perpendicular bisector and it cannot be an altitude. It must be the median. So sometimes, guys, even if you don't know what that segment is, you can figure out what it is not, and that will help you determine what to do. Okay, last page.